Hello, so today we're going to go over solutions, which is Unit 3, Lesson 11. Sorry that the OLS is down again, but I'm going to make this recording so we can stay on track. So what is a solution? So we're going to look at some terms. So you have solute and solvent. So the solute is the substance that gets dissolved, and the solvent does the dissolving. So in this case, if you think about salt water, the solvent is the water, the solute is the salt. So a solution is a mixture of two or more substances that is identical throughout, and it can be physically separated. So if you think about salt water, we can evaporate the water and get the salt. So all solutions are made of a solute and a solvent. So if you think, another way to think about it when you think about like a solid solution instead of like a liquid solution is most of the time the more abundant substance is going to be your solvent. The least abundant will be your solute. Not always the case, but that should help you when you think about like a solid solution instead of a liquid solution. So a solute plus a solvent equals a solution. So solute is part of the solution that is being dissolved, usually the lesser amount. The solvent is the part that does the dissolving, and is usually the greater amount. So soluble and insoluble. So a substance that is soluble can be dissolved. If it's insoluble, you cannot dissolve it. So electrolytes are liquids that are capable of conducting electricity. So if you think about some of the changes that a solution can go through, so the amount of solute in a solution determines how much of the physical properties of the solvent are changed. For example, by adding more solutes to a solvent, you can change the freezing point and the boiling point. So when we make a solution, we have to have the solvent and the solute. So the solvent particles are attracted to the solute particles. So this is called a solution. With the solvent water is called a hydration, but don't worry about that too much. So remember that likes dissolve likes. This one might be a little hard for you guys to understand at the moment, but basically, if water is polar, so it has negative and positive parts of the molecule, then anything that's polar is going to be able to be dissolved in it. If it is nonpolar, then it can only dissolve nonpolar substances. So if you notice water and oil are not on the same side, and you can see that when you put oil and water together, they don't mix, so they don't make that solution. So that's how one way you can think about it as polar versus nonpolar. Toluene I've worked with, benzene I've worked with a ton. And same thing with acetone. So acetone here would be like a fingernail polish remover. Some of them are acetone free, but a lot of them still have acetone in them. So this is a flow chart to kind of help you understand how everything is made up. So you can start with the matter, go to a mixture, then come down to a solution, and then a solution can be broken down to that solute and that solvent. Alright, so can you see two parts in solutions, or are they mixed together so well you can only see one thing? Well, think about salt water. You can't see each individual salt grain in the water, so you only can see one thing. So that's what's special about a solution, is that it looks like it's one continuous even thing, but really you can separate each part out physically. Are solutions mixtures or pure substances? They are mixtures. So what kind of states can they be in? Well, they can be in a solid, liquid, or gas, just like any other pure substance. And then what are the two S words that every solution must have? Well, that's your solute and your solvent. So in a saltwater solution, is salt the solute or the solvent? So it's the salt doing the dissolving or being dissolved. So it's being dissolved, so it's a solute. Is water the solute or the solvent? So you can think, is the water dissolving or is it being dissolved? Well, it's doing the dissolving, so it's a solvent. So what does a solute do? It gets dissolved. What does a solvent do? It does the dissolving. So a saltwater solution, so you have the solution, you have the water, that's the solvent, and you have the salt, that's the solute. So here we have the regular salt that's going in, and then once it gets down here, it becomes the solute. So what can speed up the rate of, or the dissolving? So if you shake it or stir it, so think about if you're making Kool-Aid, you can pour the packet in there and eventually if you let it sit, it's all going to dissolve into it. But if you stir it, it will actually dissolve faster. So if you break it apart, so you make it into like smaller pieces. So instead of like a big huge sugar cube you drop in, if you put powdered sugar in, it will dissolve faster. If you heat it, if you use warm water to mix in sugar or salt, it's going to dissolve a lot faster than cold water. And also the amount of other solutes that are in the solution can also affect the solubility. However, extra time stirring or shaking will have little effect. So once you get everything pretty much mixed in, like if you're making Kool-Aid, if you keep mixing it, that last little bit is not going to make it any faster to dissolve. You're still going to be sitting there and basically wasting your energies mixing it because it's not going to help it dissolve any faster. So is it soluble? So not all charged compounds or ions can dissolve in water. So that we have our solubility tables, and we also have some rules that go along with this. So in reality, ionic compounds all dissolve to various degrees. So you might have one that might dissolve 50%, you have one that might be 5%, might have one that's 100% dissolved. So they do vary in how much they do dissolve, but we're looking at completely dissolving them. So we'll look at the table here in a second. So the solubility depends on the temperature, and it depends on the physical state of the solute and the solvent. And it also depends on the gas pressure. So now if you look at the solubility curve, so here we have temperature along the bottom, and we have the amount of solute in grams, and that's for each of these chemicals. Each of these compounds that are listed goes with the line that it's pointing to. So HCl here is hydrochloric acid. So if you notice, it goes down, the solubility goes down as the temperature increases. So here, we want to know which one has the smallest increase in solubility as temperature increases. So if you look down here, you see the temperature. If you look at the graphs, you want the one that changes the least going from left to right, because that's the increase in temperature. So which one does that? Well, NaCl. If you notice, it's it's a straight line going across there. And so if you look see which one is the greatest, as temperature increases, you want to see which one has changed the most as you go from left to right, so as the temperature increases. And for that one there, you can see it's KNO3, because from where it starts down here at about 9, it shoots up to to 180 up here. So it changes the most. And to explain the relationship between temperature and solubility, it's in most cases, increasing temperature of a liquid solvent will increase the solubility of a solid solute. So these were all solids to begin with. And for the most part, as we increased that temperature, we did see that more of it was dissolved. So many reactions warm up when you mix them, so they're exothermic, so they give off heat. But some actually get colder when you mix them because they're endothermic, they need heat to be absorbed into them to react. So concentration, we have a solution that has a lot of solute per solvent, we say it's concentrated. If it's diluted, So think of a solution that has a lot of solvent. So if it's concentrated, think about you making Kool-Aid and it's supposed to make 1 liter per packet, but you put in 2 packets for a liter. There's going to be a lot of that flavoring that's in that, so it's going to be really concentrated. But now at the same time, if you want to have it diluted, so instead of using a packet to a liter, you might actually use a half or a fourth of the packet to the liter, so it's not going to be as strong. So then you're going from that concentrated state to a dilute state. And saturated is a solution with a maximum amount of solute that it can hold. So if you think about you have a liter and you keep pouring packets of the Kool-Aid into it, you're going to get to a certain point where it's not going to dissolve anymore. You're just going to see it sit at the bottom, and no matter how much you shake it, it's not going to dissolve. But we also have what we call supersaturated. So it's a solution with more than solute than it can hold. So that one there you have to be really careful, because a lot of times you have to heat those up to high temperatures to get everything to dissolve. And then there are some cases where you can actually start pouring out the liquid and you'll see it when it like instantly freezes, and freezes in quotation marks there because it's not actually freezing, it's just coming out of being super saturated into just regular saturated. So it's going from that liquid to a solid form, so it's not actually freezing, it's just becoming unsaturated. And so if you actually jostle that container before you pour it out, it can all crystallize inside the container. Alright, so that goes over lesson 11 for unit 3. If you have any questions about any of this, please make sure you let me know. Thank you.